This is a demonstration made about 50 years ago by a test pilot of the German Luftwaffe. Demonstration was made on this field in the East Coast. I can't remember his name right now. But the Ladislao Stork is a unique airplane, mainly for the very low speed it can fly, can compete with autogyros. And here is the takeoff of the autogyro flying tandem with the Ladislao 156. Notice, by the way, the main cranking up with the wheel crank the starter, so the starter was manual. Both airplanes climbing, and it's about the same performance as a good quality autogyro. See, many different tests were made with this aircraft by the German. One of them was to, well, most of what we see in this film are stall landings. Notice that the airplane has the flaps up, out, and it's coming for a landing and just practically drop it from the sky. Has a very large landing gear which absorbs a lot of energy. Also interesting to know is the flat turns. You see that the aircraft does not have bank inclination. It's flat, and it does not go into any vicious situation with that, with the flap. Landed already a second time, and take off and immediately stall it and just drop out of the sky and hit the ground with the oleo spring shock absorber. Still the flaps are out and turning in a flat position. The German used the airplane for liaison, rescue, observation, and any other low speed characteristic which was required. One of them was the rescue of Mussolini from the top of a mountain. The aircraft was used to test some new ideas on rescuing people out in the water by unreeling a long rope from the fuselage and let the man on the water to grab the end of the rope and practically suck him out from the water. Demonstrations were made with one people on board the test pilot and also with two people, which are hardly noticeable any difference. The construction of this aircraft was typical 1940 technology. The fuselage is a welded tube, 4130 welded tubes, and the wings were made out of wood. The entire aircraft fabric covered. With the PL-9, we used similar technique. The fuselage is welded tube. The great difference is that the wing is aluminum sheet metal. Easier these days to obtain than good quality wood. The tires were 505. The engine for this aircraft was the Argus 210. Notice the large excursion of the rudder. This aircraft, you use plenty of control displacement. Not too much speed to do any great dynamic testing. The stall speed was in the alrededor around 30-32 miles per hour. This is in Rialto, California, where the project was started. And this, what you see here, is the welding jig for the fuselage, which permits direct welding without overhead problems.
Well, what do you think? Is it big? How long it is?
It's huge. What you're looking at there is approximately 20 feet. You'll have another 3 feet or so of rudder and probably 5 feet of engine out there with a spinner. You're probably talking 26 feet easy. It's a big airplane.
And how about the jig, the welding jig? Well, can you rotate the jig?
Yes. We removed this pin, the pin on the other end, and it goes right on around so we can weld at any angle, any position, any part of the airplane.
How about the space inside, Bob?
More than adequate. It's huge. It's every bit as wide as the 182, I think. It's, well, not quite. It's this being tandem, but it's very wide. You have all the shoulder room you're going to need in there. Plenty of room. Plenty of visibility. It's going to be a fine airplane for traffic control, spotting, fish spotting, whatever. It's going to be a fine airplane.
Now, how long before you think you finish completely welding the primary fuselage?
This fuselage should be ready to take out of the jig and mount the gear on probably by March.
A month?
March.
Oh, in March?
Yeah. I mean, that's with all the standoffs, everything. So,
Everything.
So there'll be no more welding necessary on the fuselage.
I see.
That'll be with the controls, everything.
Yeah.
Probably be around March. I'm going to try, of course, to get it done as soon as possible. But
Can you show us the rotation of the jig?
This is the welding jig for the fuselage. A large diameter horizontal tube serves as the backbone, and the individual little length of tube forming the frames are welded to this tube.
Let me see it, what you're doing, Bob.
I'm removing these 2 bolts. There's one on each end that prevents it from rotating unnecessarily.
The man is removing the blocking bolt, one on each bushing at the extreme end of the fuselage.
I have to get the bolt.
And by removing that bolt, the entire fuselage can rotate around that steel tube. Now this is the kind of tooling that will be used for kit manufacturing. The typical amateur builder will just make his own layups.
About any angle you want to work on it.
That's great. What welding are you using for the whole fuselage?
The whole fuselage will be heliarc welded
Heliarc.
with our 1265 heliarc rod. Press relief wherever necessary.
Put it back again upright, please.
Accommodating the individual half-finished frames around the jig tube, which can be tested for alignment. Very simple way of doing it. Here are some of the individual panels, like you will build it on a factory.
Make sure
for kit manufacturing. The technique will be different for the amateur builder and is described on a number of airplanes, showing the assembly of welded tube fuselage fabric covered. We are not going to describe that technique because it's well known. Just like I'm not going to describe wood fabrication or aluminum sheet metal fabrication, because these are techniques that are used very often. That we've seen a cluster of welding here. This is the elevator aileron control. Everything is bronze bearings, is designed and built like a factory-made airplane. This is a fiberglass fairing for the main tube on the landing gear. Again, the technique to mold these things are well known. Just follow the drawing. What you see here are ribs probably for the vertical tail, made out of fiberglass, and there are simple layups and will fed to the assembly. That's the model of the Fieseler. This is a static test of the main landing gear, which was mounted on a jig loaded up with cement blocks to simulate half of the weight of the airplane. This is the beginning of the construction of the Pazmany PL-9 prototype. This sequence that we see now were made in Rialto, California, and what you see on the floor are some individual jigs to weld the frames. The individual jigs to weld up the frames were assembled completely utilizing a rotary jig, which is a heavy gauge tube used as a backbone, and the individual frames are welded precisely on this rotary tube. The main objective of the rotary tube is to permit overhead welding for every position of the frame. You don't have to weld upside down. This is a close view of the fuselage jig, and you can see here the heavy 2-inch or 3-inch diameter tube used as a backbone frame to locate and weld all the components. This is the front end of the firewall. You can see it on at the right side of the jig. These are aluminum, sheet metal aluminum ribs were molded over a simple mold cut out from hardwood or plywood, and the way you build these things is well known as a number of airplanes and textbooks, so I am not going to repeat those things which are well known, such as welding or forming aluminum ribs. Just like to point out that these ribs were made with the aluminum and the SO condition, which means the final molding is done right here and you don't need heat treatment. This is the tail end of the fuselage, and you can see that the vertical tail, which is a construction of sheet metal ribs and skins, the vertical tail is bolted to the tubular structure. The rudder is mounted here on the tail end of the aircraft. It is shown as a sheet metal covered structure, which was a mistake. It has to be fabric covered, and that was easily corrected by removing these mistake skins. The people in Rialto made up a little homemade hydro press to form all the sheet metal components. The hydro press consists on a platform which goes up and down, compressing the aluminum, and it's pushed by a heavy hydraulic cylinder, hydraulic jack. In a one single stroke operation, you form each rib. So if you ask me how long it takes to build a rib, I would say 1 minute. The aircraft at the beginning of the program was built quite a long way at Rialto, California, but then it was moved to Jakarta in Indonesia. A good old friend of mine, Ruben Hardy, financed the operation of moving the whole thing to Indonesia, and that's what was done here. Here you see two Indonesian young fellows pressurizing the main landing gear strut. A detailed close-up of the cockpit area can be seen here on the right side, and shows two doors, one after the other door, for easy access to the cockpit. Otherwise, everything is very common technique and technology, nothing new here. It's just welding. Be a good welder. This is an overall view of the fuselage. Probably what they are doing here is check for failures on the tube, gaps or cracks by penetrant die inspection. It was a very good welding job. We don't have any problems. Here the people in Indonesia, they covered the inside of the fuselage with noga hide, which is a very nice material for protection of your tools or foot, but it adds weight to the assembly, and I strongly recommend it to remove it. We will see in the future what happens. A close-up view of the front door, and you can see the specially made fiberglass seat, molded seat, which is here. It came out a little bit heavy, so this will be redone for getting the weight back to where it belongs. Another close-up view of the fuselage, and they are testing with compressed air probably for leaks. The fuselage inside lining is being fit here to the cockpit. The plexiglass windows which covers the whole cockpit are flat plate plexiglass, do not need forming or heating and forming. It's just flat plate and bent over the frame and attached to the frame. This is a view of the installation of the Subaru 2.2 liter engine and from firewall forward it's all provided by the Subaru people to have the first shot of the Subaru 2.2 liter installation of the aircraft. This is Mr. Ruben Hardy, who financed the construction of the prototype in Jakarta. This propeller was designed by Moises Salmoun from California. He's an expert propeller designer, and manufactured by Mr. Felix. He has a company someplace on the Middle East, and it fits the 1500 RPM on any engine with the reduction gear of 2.2 to 1, which I should mention. This is not a direct drive engine, it's a reduction driven engine propeller. This picture shows the construction of the wing spar, in this case the rear spar. which is sheet metal webs with bent flange, and then riveted to the skins and the ribs. This is adjusting the nose ribs on the wing into the jig, which is nothing but a series of wood standoff, leveled, and then the skins are drilled in and riveted, most likely with pop rivets. Part of the weighing of the aircraft, which was done in several occasions to keep track of the weight and balance of the aircraft. So these are scales, and the main tires are located on top of the scale, and the weight is registered. The elevator, with a basic structure of sheet metal ribs and frames, and entirely covered with fabric. The front end of the fuselage with the engine removed, but show the large radiator which goes between the firewall and the engine. This is a collection of fiberglass parts which were all made on the factory. That's a very easy technique, anybody can do that. All the fiberglass parts were made at Jakarta. The main landing gear assembly, one side of it, was mounted on a jig which can move up and down, and it was loaded with, I think it was cement blocks to simulate the engine, the weight of the aircraft, and dropped at a certain altitude according to the specification by the FAR to obtain the shock absorption characteristics of the gear and tire, and it came out very good. It's very successful. This type of gear, oleo pneumatic, I used on several other light airplanes with good success. The view of the top of the cockpit. Here's the front spar of the wing and the rear spar, and you are looking straight down inside of the cockpit. And this is all plexiglass, so you have excellent visibility in any direction. The Subaru Legacy 2.2 liter was considered from the very beginning, and it has a reduction gear of 2.2 to 1. This is the wood propeller made by Felix. The cowl was improvised by the Jakarta people with flat sheets bent around, and it came out too heavy, too large of the size of the cowl. This has been remade, we will see later on. The air inlet for the Subaru engine, immediately after it is the large radiator, the liquid-cooled radiator. There is not enough cooling area right now the way it is, although they just built it up to add some more area on the radiator. The engine was overheating. Subaru Legacy installation, looking down. It's quite busy. There's a lot of material put together here. The 2.2 liter will be very marginal on providing the 150 horsepower at maximum RPM. So another engine is being adapted right now to provide for more power and more cooling. The propeller and propeller reduction does not change. There is a replacement engine which should work very well, and that is use some of the Lycoming 0320 These are off-the-shelf aircraft engines, and it should do the job very well. I made the plans for the installation of the Lycoming O320. These are optional plans, but it will do the correct modification of the installation. This is a photo inside of a cockpit. Quite roomy, quite conventional. Control stick mounted on a bell crank here, directly actuating on the ailerons. This is the flap control, which has a handle that you turn on about 3 or 4 turns, and by means of a bicycle chain, just like is done on the real airplane, the real fuselage, you lower the flaps independently of the ailerons. But you get, with flap down, controls excellent. The controls work very well. This is a view of the upper forward corner of the cockpit. What you see there is the nose spar, which goes through and connects with the fuselage. And the aileron and flap controls are all together here, which makes it easier to remove a couple of pins and fold the wing. A view of the tail gear. Originally, I designed specifically a tail wheel like this and mounted on the aircraft. On the first flight, we noticed that it was some shimmy on the tail wheel. To make it to expedite the design and the construction, I changed the tail gear by a standard commercial tail gear assembly, which is working perfectly. Later on we will fix the main gear. This is a view of the engine compartment, and there is nothing extraordinary, it's just common practice. The engine is mounted from the beginning with the Subaru on dynafocal elastic rubber mounts. 1, 2, 3, 4, someplace here. So the engine is supported in 4 engine mounts, dynafocal, which means that it reduces the vibration of the engine. I made a mock-up of the engine mount for the Subaru 2.2 liter, and this is this mock-up made up of fiberglass or plastic tubes just glued together to give me the actual location of the 4 points for mounting the engine. 1, 2, 3, 4. It's a tray mount. The engine is sitting on a tray and has very good access to any components. Part of the mock-up of the engine mount, and you see here simulated 2 of these rubber donuts which support the engine. We see 2 of them here, 1, 2. These are fiberglass molding of the fairings. What you see here are the trailing edge of the elevator and the rudder, and they are conventional fiberglass layup. With very little experience you can do a very good job. This is confusing because the brick background, but the molded fiberglass fairings for the landing gear are here. These are cuff, which goes and covers the long strut for the main landing gear. Close-up detail of the fiberglass parts used on the elevator and other controls. Eventually, we will have a kit manufacturer to make this thing on request. A good close-up of the cockpit area. You can see that you have a very easy access. These windows are moved up, swinged up. The aircraft, the finished aircraft, or almost finished aircraft, in a hangar in Jakarta.
This is Ray Cody. He's climbing into PL-9 for the first time. It's September 28th, Sunday afternoon. And shortly he'll be taxiing down to the start of the runway at Brownfield. And he'll proceed to do about 3 taxi tests. And then he'll come back here to the hangar and they'll check out the engine. And then he'll go out again and he'll make his first flight. Ray's now getting a checkout with Al on the instruments, and shortly he'll be starting the engine.
The aircraft with the 2.2 Subaru engine did not respond too well. The power developed by the engine was not as promised, 150 horsepower takeoff. So we were able to do just practically taxi test. And here is the aircraft being prepared for taxi test and jump.
Got the tail up.
The aircraft after this test was taken back to Indonesia to install a more powerful 2.5 engine. This is a view of the aircraft in static exhibit at the Oshkosh Convention, 1999. The aircraft is equipped with an enlarged cowl, and it improved the view of the aircraft quite a lot. It's propelled with a 3-bladed graphite propeller. Otherwise, everything else as before. Another view of the firewall area with the large cowl removable here. Otherwise, it's quite conventional. This is a view of the cockpit area. Very large visibility, windows all over, permits to look straight down underneath of the airplane. View of the cockpit area, looking at the seat. This is a view of the engine, the 2.2 engine mounted on the airplane. At the present, we are expecting a larger engine, the 2.5. A view of the commercial tail gear. This is absolutely conventional and it works very well. This is a picture of the aircraft at the EAA convention at Oshkosh. Before I forget, I should mention that the wing folds on this aircraft, so you can move it in over the fuselage and take it on a trailer, move it around. Otherwise, everything else is conventional. Now it is being flight tested with the 2.5 Subaru engine. The handling in the air is exceptional. The stability and controls are excellent. The plans to build the aircraft by amateur builders are excellent, are very complete, covers every detail, and it will be easy to follow by inexperienced amateur builders. The possibility of having some people making kits of the aircraft is very good. We will have some response on this as soon as the flight testing is finished. It's very possible, almost sure, that after the flight test, including all the opinions and comments from the qualified test pilot,